600 million kilometers from Earth, suspended in the lethal radiation belt of Jupiter, hangs a frozen vault of ice. This is Europa. On its scarred, bone-white surface, temperatures never rise above -140 degrees Celsius. It is a world of absolute desolation, locked in a permanent, silent freeze. Yet, beneath this planetary armor of ice lies a dark, warm, liquid ocean holding twice the water of all Earth's oceans combined. For billions of years, this abyssal sea has remained sealed in total darkness, completely cut off from the sun, energized only by the gravity of a gas giant. In this pitch-black graveyard of ice, the ingredients for life are not just possible, they are waiting. For centuries, humanity looked to Mars as the next frontier in our search for cosmic neighbors, searching its dry red sands for the ghosts of ancient rivers. But the true holy grail of astrobiology lies in the outer solar system, where sunlight is nothing more than a faint star. Europa, Jupiter's sixth moon, has shattered our terrestrial bias that life requires a warm star to survive. It challenges our fundamental understanding of biology, suggesting that the spark of life does not need a sky, it only needs a spark of heat from a world's bruised interior. To find this life, we must look beneath the ice, into a pressure-cooked abyss where Earth's rules no longer apply. To understand the mystery of Europa, we must first look at its bizarre, chaotic surface. When the Voyager spacecraft screamed past the Jovian system in 1979, scientists expected to see a heavily cratered, dead rock, similar to our own moon. Instead, they found a polished billiard ball of ice, crisscrossed by thousands of dark, red-brown fractures. These massive cracks, some stretching for thousands of kilometers, are called lineae. They are the stretch marks of a moon under immense gravitational torture. Because Europa has almost no impact craters, geologists realized its surface is incredibly young, constantly being recycled, paved over, and healed by fresh water welling up from below. The red-brown stains bordering these fractures are not dust, they are mineral salts, blasted by Jupiter's radiation, hinting at the complex chemical soup churning just beneath the crust. This is not a dead block of ice, but a dynamic, breathing shell that acts as a protective shield for the colossal ocean hiding below. At 5 times the distance from the Sun to Earth, Europa receives only 4% of the sunlight we do. Liquid water should be an impossibility here. Yet, Europa's ocean is kept warm and fluid by a process known as tidal heating, a violent cosmic tug-of-war. As Europa orbits Jupiter in an eccentric, oval-shaped path, it is caught between the immense gravity of the gas giant and the gravitational pulls of its sister moons, Io and Ganymede. This orbital resonance forces Europa to constantly stretch and compress. The moon literally flexes by up to 30 meters during its 3.5-day orbit. This continuous physical deformation generates immense internal friction, melting the lower layers of the ice crust and keeping the global ocean in a liquid state. It is a gravitational engine, transforming the kinetic energy of orbits into thermal energy, ensuring that while the surface remains a frozen wasteland, the interior remains a warm, churning cauldron. Earth's ocean life relies almost entirely on photosynthesis, where plants convert sunlight into energy. But on Europa, where the ice shell is estimated to be between 15 and 25 kilometers thick, no photon of sunlight has ever penetrated. If life exists here, it must survive in absolute, permanent darkness. For answers on how this is possible, scientists look to the deepest trenches of our own oceans. Near hydrothermal vents, where superheated, mineral-rich water spews from Earth's mantle, thriving ecosystems exist completely independent of the sun. Microorganisms feed on toxic chemicals like hydrogen sulfide through a process called chemosynthesis. If Europa's rocky seafloor features similar volcanic activity, heated by the same tidal forces that warm its water, these hydrothermal vents could be the cradles of life. They would provide the heat, the minerals, and the chemical gradients necessary to spark the transition from organic chemistry to living biology. Life cannot exist on water and heat alone, it requires a delicate balance of chemical ingredients. Specifically, it needs oxidants, electron-accepting compounds like oxygen, to react with reductants, which are electron-donating compounds like hydrogen. On Earth, photosynthesis provides a bountiful supply of oxygen. On Europa, the process is reversed. Jupiter's intense radiation belt bombards the moon's icy surface, breaking apart water molecules into hydrogen and oxygen. The light hydrogen escapes into space, leaving behind highly reactive oxygen and hydrogen peroxide. As the ice shell flexes, cracks, and overturns, these surface oxidants are dragged down into the subterranean ocean. Meanwhile, hydrothermal activity at the seafloor releases hydrogen and methane. This constant downwelling of oxidants and upwelling of reductants creates a massive planetary battery, supplying the chemical energy needed to fuel a deep-sea biosphere, potentially sustaining everything from single-celled microbes to complex, multicellular organisms. To confirm the existence of this hidden ocean without drilling through miles of incredibly hard ice, scientists had to look for leaks. In 2012, the Hubble Space Telescope detected something extraordinary: towering plumes of water vapor erupting from Europa's southern polar region, reaching altitudes of over 160 kilometers into space. These giant geysers act as free samples of the interior ocean, blasted directly into the vacuum of space. By flying spacecraft directly through these plumes, we can sniff the chemistry of Europa's ocean without ever landing. NASA's Europa Clipper mission, currently hurtling through the solar system, will perform dozens of low-altitude flybys, utilizing advanced mass spectrometers to analyze the composition of these plumes. It will search for organic molecules, amino acids, and the chemical signatures of life, potentially confirming that the ingredients for biology are currently drifting through the cold vacuum of the Jovian void. Europa has forced us to redefine what makes a world habitable. It is a reminder that the universe does not revolve around our yellow star, and that the spark of life may be far more resilient and far more common than we ever dared to believe. If we find even the simplest microbes clinging to the hydrothermal vents of Europa, it will mean that life is not a terrestrial anomaly, but a cosmic inevitability. The dark, silent ocean of Jupiter's frozen moon is a mirror reflecting our own origins, waiting for us to finally pierce the ice. Subscribe for more cosmic deep dives.